Hello, and welcome to the Cyborg Zombies Physics Special. Today, we're going to be solving the FedEx Physics Challenge. Now, FedEx gives out this challenge every year to first robotics teams just like ourselves. These challenges can range anywhere from education to engineering, and we happen to get physics this year. So, let's start breaking this down and solving this physics problem.
It is lovely, isn't it?
Right.
Did somebody say physics? It's like my favorite subject, after like shopping.
So, is there any way we can determine the maximum angle that the ramp could possibly be at?
Don't know, and don't care.
Why don't you research it?
Well, from here we can see that the length to width ratio is actually 1 to 12. So using that, we can figure out... Steve, what does that say? I can't read the teleprompter and I have no idea what's actually going on.
Inverse tangent of 1 over 12, you solve for it.
The inverse tangent of 1 over number equals the inverse theta, and the actual number is 4.67.
4.76 degrees.
What she said.
Fahrenheit or Celsius?
No, degrees, like the measurement derived from a circle.
Okay, let's just get to solving the problem.
Yes, we'll start off by saying that the gravitational acceleration is 9.81 meters per second squared.
Wait a minute, no. The problem is given in imperial units, so we should say that gravitational acceleration is equal to 32.2 feet per second squared.
Metric is superior.
I know, we'll start by drawing a diagram. Like this one right here. Hold that.
Can we have glitter glue on it?
No, that would ruin the mathematical perfection. But we can use Kugel for Sharpies. See this pretty picture? So the force of gravity is like this cute pink arrow. And the normal force, which is actually the force of the ground pushing up on the wooden crate, is this adorable little blue arrow. And then there's the force of friction, which is caused by the two surfaces sliding against each other, opposing the force of the push. That's right here. So here's the math, and here's my answer.
See, I told you we should have used imperial.
Metric is still superior.
Those silly gooses, we use variables. So gravity, the teacup, is right here. And when you multiply it by mass, which is the heart, you get a big, giant smiley face. There's the definition of frictional force right here, which is mu, like a cat, times the normal force, which is equal to smiley face, because I equated math to get smiley face and a normal. So friction is cat times smiley face, and that makes a happy cat right here. So the force of the push of bunny is equal to the force of happy cat, and you just plug in numbers and bam!
Well, she's not wrong.
She's not right.
Well, bunny, which equals the force of the push, equals 160 pounds of force.
She is right.
But what's all this stuff down here? I mean, all this secondary stuff, what is that?
It's exactly the same.
What?
Look, it's just an angled star, and it's already been solved for. So since it's at an angle, I rotated my axis so that now the force of gravity, or teacup, contributes force in both the x prime and the y prime direction. So star over here equals star over here. Also, since it's at an angle, the normal force is a little harder to solve for. You gotta use the cosine of star times smiley face. I call that happy cosine star. And in the x direction, there's also the force of gravity, which is the sine of star times happy face. So it's happy sine star. Put all that together and you get the force of the push. So bunny is equal to happy cosine star plus happy sine star times happy cat from before, except it means different.
I beg you to use standard variables next time.
But look how it is cute.
It would have been much clearer.
Well,
At least we got the problem done.
and she's right, you know. I
Can't
looked
take
up
this
online afterwards. It's right.
That's cheating.
Okay, well technically I cheated. You guys didn't, so still good, right?
We as a group need to uphold moral standards.
Xander, you cheated. I'm going to go tap.
Was she gonna go tell?
Don't care. But metric would have been much better.
No, imperial. Here, look. See right here? 1 slug over 32.2 pounds. That conversion is exactly the same as gravitational acceleration. So it's super clean, and this entire problem was basically written for imperial.
I know. I'm not gonna be your guys' stand anymore. It's your problem now.
But imperial it's messy. It's not base 10. It's not meant for our number system.
But do you see how clean these calculations are?
We should not have to use imperial. It should have been set up in metric to begin with.
True.
CZTV, physics scene. Roll 1, scene 1, take 6.
Oh, that's a
Roll 1,
No.
scene 1, take 7.
I know how to
behind
For the
start.
record, Daniel didn't study his lines. TV physics special, roll 1, scene 1, take 8. CZTV, physics special. No, I screwed up too. Roll 1, scene 1, take 9.
Okay.
CZTV, physics special, roll 1, scene 1, take 11.
Scene 1, take
I have
300.
to edit this though.
Where's the happy cat?
I don't know.
Where's the happy cat?
Happy.
Don't show my face.
Show her face.
Wait, Reed, in this scene,
I should be up for at least one.
what is that? I don't see the
Figure out that. Carl, what does the teleprompter say? I can't read that.
Why did you say Carl?
Ah! What about all of this?
I
All
will
this
smack
second
you. I will smack you in the face.
stuff? Oh.
Hey, wait.
We can
What?
just take
What?
the shot now.
Okay, so it's gonna be like.
I can have
What
liquid.
do you want
Where
to do?
does that go in here? But I can walk
Okay,
in.
let's walk in.
So if we use that, we can.
Not screw up on our lines.
That wasn't actually.
That was in
That was his